Okay, for this problem, we're doing the area between curves. It's number 3. It says find the area of the region between the following curves. If necessary, break the region into subregions first. So we have y equals 6 minus x, y equals the square root of x, and y equals 1. And I put this in Desmos here, and you can see the y equals 1 is the green one. This blue curve is the square root of x, and this red line down here is going to be your 6 minus x, as you can see over there. So we have a few things to look at. First of all, we know that this region starts at x being 1. You know at x being, if I click on there, 4, 2 is where it crosses, so 4 is the number we want. And then it's done here at 5. So we really have two different regions to look at, from 1 to 4, and then from 4 to 5. So from 1 to 4, we have the square root of x as the upper curve, and 1 as the lower curve or line. And then from 4 to 5 for the x values for that integral, we have 6 minus x for the upper and 1 for the lower. So when we come back over to here, we're going to have two integrals. Integral from, and I really like to use blue, so I'm going to switch to blue. Okay, so we have the integral from 1 to 4 of, and our upper curve there was the square root of x, then minus the 1, upper curve minus lower curve, dx, plus the integral from 4 to 5 of, in this case, the upper curve was 6 minus x, and our lower curve is still 1. So we have, I'm going to rewrite this a little bit, integral from 1 to 4 of x to the 1/2 minus 1 dx, plus the integral from 4 to 5. Now 6 minus x minus 1 is going to be 5 minus x. So if we integrate this x to the 1/2 becomes x to the 3/2 divided by 3/2 minus, and the antiderivative of 1 is x. We're going to evaluate that from 1 to 4. And then we have the antiderivative of 5 is 5x. And the antiderivative of x is, we got the minus there, x squared over 2. And we evaluate this from 4 to 5. Okay, so let's clean this up a little bit more. That x to the 3/2 over 3/2 is going to be 2/3 of, now I can put the 4 in there, 4 to the 3/2 minus x is the 4, then minus, put the 1 in there, 2/3 times 1 to the 3/2 minus 1, plus, and probably don't need the bracket, plus we have 5 times 5, that's the upper limit of integration, minus 5 squared over 2, minus the quantity 5 times 4, minus 4 squared over 2. So now it's just a matter of working out the arithmetic here. So the square root of 4 is 2, 2 cubed is 8, so we have 2/3 times 8 minus 4 minus 2/3, because 1 to the 3/2 is just 1, plus 1, plus 25 minus 25/2, and then we have minus 20, then we have minus negative makes it plus 16/2. And I know that's 8. I'm doing things in steps here. Okay, so we have 16/3, and let's look at our constants. We have minus 4, plus 1 is minus 3, I know the math, and then minus 3 plus 25 is minus 22, or plus 22, excuse me, 22 minus 20 is 2, so we have a plus 2, and then I have this minus 2/3 here. Oh, maybe I should have done that. 16 minus 2/3, that would have been 14/3. So we have our 14 thirds. Let me just do a little check mark over what we've done. Simplify that, and this, and this, and this, and this. And it's tempting to say, oh, and I saw a major error. That was 16 halves. Sure that I'm going to get a comment about that. Okay, now I know that 16 halves reduces to be 8, and that's what I was thinking when I wrote the 8 down there. But we have minus 25 halves plus 16 halves would make that a minus 9 halves, right? So that lets us resolve this and this. Okay, good. So we can see the common denominator is going to be 6 out of all this. So I have to multiply this first one by 2 over 2. So we end up with 28 sixths plus 12 sixths minus 27 sixths. So 28 minus 27 is 1. Plus 12 is 13, so it's 13 sixths, and that's the answer. Okay, hope that makes sense.